Islands can be large landscape-scale features like coastal barrier islands, or smaller islands like those found in estuaries or in the Great Lakes. Regardless of their size, though, they provide valuable habitat, recreation opportunities, and coastal protection in the form of reduced erosion and wave energy to nearby shorelines. These benefits are derived from the fact that islands often consist of multiple habitats that span different elevations, like beaches, dunes, and marshes. Multiple habitats in succession are really equivalent to a multiple lines of defense strategy. That when combined, these habitats are more effective at reducing waves and erosion than a single habitat type alone. Unfortunately, islands are disappearing at an alarming rate, especially along the Gulf of Mexico and Atlantic coasts of the US. In these areas, we are losing valuable habitat and the protective function provided by islands. This makes the restoration and creation of islands, especially with the beneficial use of dredged sediments, valuable in terms of increasing habitat and protection for nearby shorelines, all while keeping sediment in the system. This is what the Baltimore District has done by restoring Swan Island. The Swan Island restoration presents an excellent research opportunity to evaluate island performance and inform future monitoring and adaptive management strategies.
Swan Island is part of Martin National Wildlife Refuge. First established in 1954, the refuge is over 4,400 acres and was established for the conservation and management of migratory birds. As part of the National Wildlife Refuge system, these lands are managed to conserve fish, wildlife, and plant resources for the benefit of the American people. While the refuge is important to fish and wildlife populations, the refuge also serves to buffer and shelter human communities on the island as well. The tidal marshes of Martin National Wildlife Refuge absorb the wind and the wave action from the open Chesapeake Bay, helping to protect the folks that live on Smith Island. The refuge's tidal marshes support many thousands of wintering and migrating waterfowl. Isolated upland areas provide safe nesting habitat for some of the largest and most diverse wading bird colonies in Maryland. The shallow, sheltered waters in and around the refuge provide important habitat for many recreational and commercially important finfish and shellfish, including the iconic blue crab, one of the most important fisheries for the local economy. Unfortunately, island habitat across the Chesapeake Bay is being lost at an incredible rate. Erosion, coupled with subsidence and sea level rise, are driving the loss of island habitats throughout the Chesapeake. Nearly all the islands in the bay are greatly reduced in size, and many have disappeared entirely. Over the last 60 years, the western shoreline of Martin National Wildlife Refuge has eroded at a rate of 6 to 15 feet per year on average. This equates to the direct loss of habitat for fish and wildlife and other ecosystem services. Projects like Swan Island offer hope. The use of dredged material to restore and rebuild these vital island habitats is a win-win situation. It provides a location to place the material dredged while maintaining important navigation channels, but also provides a means for getting important island ecosystem restoration work done. What is particularly exciting about the Swan Island project on Martin National Wildlife Refuge is that the team of partners that has come together to not only restore these critical habitats, but to evaluate and learn from the project, providing that critical, rigorous evaluation that is so important if we're going to learn and improve our understanding of how to restore these habitats.
The restoration of Swan Island occurred from the maintenance dredging of the federal navigation channels, Big Thoroughfare and Twitch Cove. While looking at ideas for placement sites, the Corps contacted the U.S. Fish and Wildlife Service, which owns the northern half of Smith Island as Martin Wildlife Refuge. While discussing with Fish and Wildlife Service, they had mentioned that they had just completed a segmented breakwater project around the northern end of Martin Wildlife Refuge, but were unable to complete segmented breakwaters near Swan Island due to large amounts of submerged aquatic vegetation, or SAV. To be able to combat that and any further erosion in the future, it was decided between Fish and Wildlife and the U.S. Army Corps of Engineers that material from the maintenance dredging of Big Thoroughfare would be placed at Swan Island to create a natural breakwater, instead of creating a concrete one just off the border. Swan Island restored about 13 acres of wetland and dune habitat. There was about 1 acre of dune habitat that was created at the northern side on the western and eastern side. The rest of it was mainly high marsh and low marsh, with about 1 acre being low marsh, and the remaining material was used to create high marsh.
In intertidal habitats, the vegetation plays a really critical role in both the structure and the function of those habitats. So that vegetation creates three-dimensional habitat that other organisms rely on for shelter and food. It also helps to attenuate incoming wave energy and therefore provides erosion control. At the same time, when that water moves into these coastal vegetated marshes and other similar habitats, the vegetation absorbs nutrients from the water quality column to fuel its own growth and therefore enhances water quality in nearshore regions. And importantly, when it does that, it also traps sediments out of those same waters. And it's this sediment trapping that, if it happens at high enough rates, can help those habitats to keep up with sea level rise over time. So in EWN nature-based solution type features like Swan Island, the goal is to create the conditions that allow that habitat to thrive. So in this case, at Swan Island, there was a very low and highly fragmented marsh system, and sediment was brought in and those elevations raised to create the physical conditions that would be more beneficial to growth of high elevation marshes and dune plants. And the idea is essentially you're mimicking what nature would do on its own, just giving it a little boost with added sediment to create conditions that will allow that system to thrive and provide the optimum benefits. And so what we're really excited about at Swan Island is the ability to investigate these relationships between the physical properties and the vegetative properties so that we can really pinpoint the thresholds of where those features perform best and where we get the maximum output.
Submerged aquatic vegetation, or SAV, are underwater plants that grow throughout the shallow waters surrounding Swan Island, as well as in other shallow areas of the Chesapeake Bay and coastal waters worldwide. Currently, SAV abundance within the Chesapeake Bay is only about a third of what it has been historically. This is due to a number of stressors, including turbid water, habitat loss, physical disturbance, as well as climate change. Research has shown that through recent management actions in reducing nutrient pollution, we have seen increases in SAV. SAV provide a number of important benefits to the ecosystems in which they live. SAV are important habitat, nursery areas, as well as provide food for a number of recreationally and commercially important species such as blue crabs, striped bass, bay scallops, and waterfowl. In addition to these important habitat benefits, SAV also help to reduce wave energy, slow shoreline erosion, uptake carbon, and absorb nutrient pollution. We are monitoring SAV beds surrounding Swan Island in order to evaluate SAV's contribution to island performance. Swan Island project will allow us to increase our understanding of how these individual habitats can work in combination to protect our coasts and coastal communities.
So pre and post construction of Swan Island, we put out 4 monitoring stations. These stations keep track of the currents around the area of Swan Island, as well as water elevations, the wave height and wave period, and the water quality surrounding the area. So the conductivity of the water, the temperature of the water, as well as the total suspended solids within the water column. We're also taking 1 sample daily of the water there to better understand what the grain size distribution of this turbidity within the water column is. So there are 2 objectives to collecting this field data. The first objective is to better understand the hydrodynamic action taking place post-construction of Swan Island. The second objective is to better inform the models we are developing to study Swan Island's current and possible future effects to the surrounding area. This includes hydrodynamic and ecological models, so we can better understand how the vegetation and the nature-based features that already existed in the region are adapting to Swan Island. So for this, we have 3 ecological models being developed. First, we have the SAV, the Submerged Aquatic Vegetation model. We have a marsh transect model to better understand how the marshes are going to react to the change in the mean sea level, mean low water, and mean high water that was created when we placed Swan Island there. And the third model is the dune evolution model. This will help us to better understand Swan Island's effect, as well as other natural and nature-based features effect in coastal and riverine areas. The impact of this study is large. We not only will better understand the effects that Swan Island is having on the Bay region, we'll also be creating and developing models that can be used for other island projects similar to Swan Island, that can be used in other locations within the Bay and around the nation.